Hello there, my name's Gary Sims and this is Gary Explains. Today we're going to be looking at the Thingy 53 from Nordic Semiconductors. This doesn't look like it when you look at this. This is actually a microcontroller development board, but unlike ones from, let's say, Arduino or from Raspberry Pi Pico, this is a full kit. You get a case, there's a built-in battery that you can be charged up. It's got all the sensors, obviously got the microprocessor on it. Everything that you would need to kind of create an actual product is kind of here as a prototyping form. Okay, let's dive in and find out some more. Okay, so let's dive into the Thingy 53 from Nordic Semiconductor. So this is what it looks like. It's a small blue box. It's got a flap on it to cover up the connectors. Inside is the Nordic Semiconductor Thingy 53 with all the chips and the sensors and the buttons, everything. We'll dive more to that in a minute. But the fact it comes in this nice little plastic box means it's usable straight away, certainly as a prototyping and experimental device. So the Nordic Thingy 53 is a multi-sensor prototyping platform for Matter, embedded machine learning, Bluetooth and other wireless IoT products. It uses a dual-core Cortex-M33 system on a chip. That's the NRF 5340. It has integrated sensors for motion, light, sound and environmental factors, that's temperature and so on. And because it uses the Cortex-M33 as a dual core, it can handle heavily computational tasks like machine learning without affecting the wireless connectivity, because that's done on a different core. So there's an application core that's clocked at 128 megahertz with 1 megabyte of flash and 512k of RAM. Then the wireless connectivity is handled by a separate Cortex M33, which is clocked at 64 megahertz and has 256k of flash and 64k of RAM, which means you don't sacrifice your wireless communication while you're using the application core for whatever task it is that you are using it. So here's a question for you. Do you have a case on your smartphone? If you do, is it thick and bulky? I'd like to recommend to you Phoenix smartphone cases. They're super slim and you'll find a link to them in the description below. It's an affiliate link. If you buy through that, you help out this channel. So it's got lots of connectivity. You've got Bluetooth low energy, you've got Bluetooth direction finding, that's pretty interesting. Bluetooth mesh, which we'll talk more about in a minute. Thread, which we'll talk more about in a minute. Zigbee and NFC. It's just got about everything you could want. Machine learning capabilities, temperature, humidity, air quality, air pressure. There's an accelerometer, there's a microphone, there's a buzzer, and it's got a rechargeable battery inside of it, which means you charge it up and you can take it away and use it in whatever setup you've got it to use it for, and it can just function there without the need of a wire. Of course, it can be powered up as well separately. You've got the flexibility there. Let's have a look at the actual board itself. You can see a lot of interesting things here. So what have we got? The microphone there, the buttons obviously. There's a power switch, is very useful, especially if you're using it on battery. You can actually turn it off, saves the power. Accelerometer, humidity, gas, temperature, gas sensor. There's the buzzer, everything. Look, you can see it all here. USB-C, which can be used to charge up the battery. Absolutely lots and lots of different things you can connect up to this little device. And talking about machine learning, the NFR Edge Impulse app, which Nordic Semi provide, enables you to connect your Nordic Thingy 53 to the Edge Impulse Studio. Edge Impulse Studio is a machine learning setup that's designed specifically for IoT devices and for embedded devices. You connect to it through your mobile device. Your Thingy 53 will talk via Bluetooth to your mobile. Your mobile will then upload to the Edge Impulse website. It allows you to wirelessly transfer sensor data over Bluetooth LE to the mobile device and then upload it to the cloud for training and so on. So using the Edge Impulse, you can basically capture data on the Thingy 53 and then using that as training data, you can come up with different things. So they give an example of, different movements of the accelerometer up and down, left and right, like a snake type pattern and so on. And they do that using machine learning. You can, of course, use the temperature sensor and the humidity sensor and any other kind of stuff you want in there to kind of build up a model where you don't have to say, with an algorithm, this is good and this is bad. The training data does that for you. Of course, that's what the whole point of machine learning is. It's also got Bluetooth low energy, and that allows it to be updated, the firmware over Bluetooth low energy, and I'll show a demo of that in a minute. And also the radio supports other protocols like Bluetooth mesh, Thread, Zigbee, and any other de facto proprietary 2.4 gigahertz protocol you want to invent. Now, the fact it supports the Thread protocol, that means the Thingy 53 is great for developing products or prototypes for using the Matter ecosystem. Now, Matter is a standardized application layer for the connected home, for smart homes, using the IP protocol as a network layer. If you're interested in more about Matter, I can recommend an interview with Chris Lepre from the Connectivity Standards Alliance. They're the people responsible for Matter, and you'll find that on the Authority Media website. That was an interview that was conducted at CES 2023. Certainly worth watching if you want to learn more about Matter. Now, talking of Bluetooth mesh, the next video that I plan in this series will be about Bluetooth mesh, how it works, what's the idea of it, and it will also include demos of Bluetooth mesh actually working in action using multiple Thingy 53 devices. So make sure you are subscribed to the channel so that you don't miss that. Okay, now programming the Thingy 53 can be done in one of two ways. You can use a firmware that has the MCU bootloader enabled in the software, and all of the pre-compiled firmware samples that come from Nordic have the MC bootloader enabled. And if you do that, you can update the firmware through Bluetooth or through the USB. Now, building your own application with the MC bootloader is not difficult, but it's not trivial either. Not like, let's say you had an Arduino and you just kind of want to flash the LED. If you just want to flash the LED and just have a bit of code that's very, very simple without all bootloaders and other kind of stuff built into it, then you can also use an external debug probe to program it. And we'll talk more about that again in a moment. So updating the firmware via Bluetooth, you can do that with the NF-RF programmer. You can find that on the Play Store for the Thingy 53. And they give you a whole bunch of pre-compiled firmwares there. And what we'll do now is just show you how you flash that over onto a Thingy 53. Okay, so here I have my smartphone and my Thingy 53. I'm inside of the NRF program. I've downloaded that from the Play Store. Now this has not got the Edge Impulse firmware on it at the moment, so that's what I want to do. So I want to install it. So you just click here on Edge Impulse. It explains what it is. It's a pre-compiled firmware that's available for us. We click on install, and it will now search for all of the Bluetooth LE devices that it can see or it can receive from. Now I've got two Ruvies sensors. I've done a video about that a couple of years ago now. They're still running absolutely perfectly. Check out that video if you're interested. But I've also got a mesh light. So that's this Thingy 53. It's currently acting as a mesh light. What we're going to do now is we're going to select it and say that we want to flash over the new firmware over Bluetooth. Look, there's no wires connected here. This is doing this all over Bluetooth LE. Let's just let that go. Okay, and there it has succeeded. So we click done, and that's it. Now that has now got the Edge Impulse firmware running onto it. And I've now gone into the Edge Impulse app. Again, you can get that on the Play Store. I've created a new project, and it's just searching, and here it is. It's found the Edge Impulse firmware on this Thingy 53. So I can say, yes, that's the one that we want to add to this project. So we'll go ahead and add that. And now, for example, if we wanted to, we could go to data, record some new data. Well, what are we recording? So you can tell it's training data. You can give it a label. You want to detect the microphone, the light, the environment, the accelerometer. We can do all these kind of things, and then you'd basically start sampling. You'd do whatever it is you're going to do on your Thingy 53, you know, drop it, wiggle it, expose it to different light or whatever, and that would then start uploading it to the Edge Impulse website, and then you can build a model from there, and then you can come down and do some inference. Just like to remind you that you can follow me on social media. All the handles are here on the screen, and I also have a monthly newsletter that covers everything I'm doing here on Gary Explains, and also everything I'm doing over at Android Authority. If you'd like to get that newsletter, go over to GaryExplains.com, type in your email address. No spam, but you will get that newsletter. Now, if you want to just upload simple firmware without the MCU boot, or you just want to have complete control of it yourself, then you're going to need to upgrade the firmware via an external debug probe. Now that means you're going to need some kind of Sega J-Link port to connect to that. Now, if you don't have a Sega J-Link debugger, then you can use the NRF 5340 development kit, because that has built into it an actual Sega J-Link port. So in fact, there's over here, you can see there's an output port, and over here there's an input port. And effectively, that means if you connect the development kit to your PC and then the Thingy 53 to the output port on the development kit, then you can program it through the development kit board. And basically that looks like this. Here's the diagrams. Here's your USB cable that connects to your PC. This is the development kit, and then this uses thin ribbon cable here to connect it over to the Nordic 53. And then to actually write the code on Windows and our other operating systems, you're going to need the SDKs and the other bits and pieces. So there is a great program called the NRF Connect for Desktop, which handles the rest of the installation. So if you install that, you can then install, you know, the SDK, you can install the VS Code extensions and so on. So you basically get that to start with, and then it guides you through the rest of the development process. Now the important thing is how you actually write code for the Thingy 53 is using Visual Studio Code. There's an extension built into it using this software that you download, and then you can just go ahead, write the code. It will recognize the board connected to a J-Link debugger or through the DK kit there, development kit there that I just showed you, and then you can just flash your software over onto it. Okay, so here I am inside of VS Code. I've got all the software installed. I was talking about using that Connect Desktop software. And here on the left, you now get an RF Connect special section. So you can click on that and you can start programming your Thingy 53. So what we're going to do is we're going to create a new application. And then this will tell us all the different things. Where am I storing it? And what do you want to actually do? Now, I think I want to try and find a quick Blinky example. Okay, so here it is. Here's the Blinky example. And they've got examples in there for, you know, just about everything, including Matter and Thread and Bluetooth Mesh. You can they've got a whole bunch of documentation. I mean, this really is well done. So we'll call this Blinky. I've obviously got one there already. Folder already exists. Let's call it Blinky 99. There we go. Right, create application. So that will go ahead and create the files that you need. Now, what you need to do before you go any further, you need to create a build configuration. This allows you to add various things to change the type of app you're building. For example, you've got the the CPU, the application CPU, and you've got the network CPU. So you can actually just configure how you're going to build this. We're going to build a simple CPU app. Let's just go away and build that configuration. And now you'll notice on the left hand side here there is this Blinky item that's appeared. Here you can find all of the source code, input files, output files, source code, including in the files from the SDK. But of course the most important thing is you drill down through application source, then main.c. This is the program that we're actually writing. It is worth noting at this point that the Thingy 53 and all of the Nordic chips use the Zephyr RTOS. It's an open source RTOS, and that's of course how they handle Bluetooth Mesh and Thread and Matter and all that other stuff. It's all built there into the RTOS. We're not going that deep. We've got a very simple program here. It does some setup, and then look here, just a while loop. What does it do? Toggles the LED and then sleeps for sleep time ms, which is defined up here as 1000 milliseconds. That's a second. So basically every second it will toggle the LED on or off. Now over here on the left hand side you've got different actions. So for example, we can click on build. That will go ahead and build the source code. Then after that you just need to click on flash, and that will flash it onto the Thingy 53 via the development kit and that debug probe and cable that I talked about earlier. Okay, so there you have it, the Thingy 53 from Nordic Semiconductors. Do tell me in the comments below what you think about it. Is that kind of thing that interests you for doing your next maker project? Would you use something like this? I do hope you enjoyed this video. If you did, please do give it a thumbs up. Okay, that's it. I'll see you in the next one.